Hello and welcome to another episode of Pokémath. My name is Stefan Eriksson and today we have reached episode number 66. And what are we going to be doing today? We're going to be taking a look at what I would just like to call unlikely scenarios. After playing Pokemon for many years, where any of you and me included, we all encountered what we deem to be highly unlikely scenarios. So today I have pictured here a Battle VIP Pass. I know one of people's favorite card ever, I know. Fantastic card. And the point is, we're going to be taking a look at something involving this, or rather, 4 of a kind. So let's get on with today's question a little more in depth in what am I actually talking about. So for today's question, our good friend here, Julius Brunfeldt, have asked this question here. So he sent this picture, or he put it up on his Twitter, in fact, and I was like, I'm going to make something on it, and luckily Julius was totally happy with it. So thanks to you, Julius, and we're going to take a look at this here today. So what are we going to be doing? The picture you have here, you're seeing now 4 Battle VIP Pass in a row. 4. And he simply asked what are the odds to draw 4 Battle VIP Pass in a row. By the way, new record. Well, I had some similar unlikely scenarios as late as yesterday when I played, but this one is unlikely. So we're going to be calculating some probabilities, and then we're going to get to some answer. But before we go any further, first, how am I going to do it? I'm going to be making use of the hybrid geometric distribution and, yes, Slowpoke, also other things, because we don't always have to use the hybrid geometric distribution. I just really like this one. Also because I teach it in a class, but I think it just makes a lot of sense. In a very short sense, as you can see here, we're trying to segment the deck into what you want to hit or don't want to hit, and the other part of the deck remaining, dividing by the amount of possible combinations that you have. So this makes use of what is known as the binomial coefficient. And I'm not going to explain all these things here in great detail because we've done it in so many videos. You can take a look at, for instance, just episode number 1. So you can just go back and check this one out if you really want to learn more about the hybrid geometric distribution, or maybe the 20 plus other episodes where I use it. But in any case, we're going to be making use of this among other things. And we're going to take it as we come along. Before we get into the actual question, one final thing. We're going to take a look at the list he played, because he was also so kind to send me the list. So for people who want to have a Palkia list, there you go. It's not bad at all, this list. It actually seems to work very well. But most important here, we see all the cards and the numbers of the cards that this deck contains. So we see 4 VIP Pass, and let's get some help here actually. Thanks, Julius, again. He provided the order of the hand, or what he deems to be the order. So 1 Palkia, there's 3 in the deck. Number 2 was a trekking shoes, also got 3 of those. And then it was water. We got 9 waters in total, and 4 VIP Pass. So this is what we're going to be looking at. And of course, when you read this, and also how I understand, there's different ways to look at this. So what we're going to be doing is we're going to answer this question in different ways. In fact, we're going to be answering this in total of 5 different ways in which way you can understand this. And I've been sorting this from the least likely to most likely. So the first one we're going to be calculating here is actually the probability that should be the lowest, most unlikely scenario possible. But let's take an overview of the things we have here. And for comparison, we're just going to place the picture here of the hand here for time to be, so everybody has a good reference of the hand we're talking about. The first thing we're going to be looking at is the exact hand. What I mean by that, we draw it in the exact order that he specified in the last slide, or in that order I think he means. Maybe Julius can actually go and provide a comment on what he actually meant with the question, but I deem this to be the least likely scenario. That is, you first draw Palkia, then choose energy, followed by 4 VIP Pass. That is what we're going to be calculating there. Then we're going to go with the first 4 cards in any order, and then 4 VIP Pass. That's little more likely. Then we do all 8 cards drawn in any order. I know he wrote in a row, but I decided to add a little other scenarios here just so we can get a nice picture of this. So you draw all these 8 cards in any order as long as you hit the 4 VIP Pass. Then we have basic in first 4, so that's just any basic. And then 4 VIP Pass. Interesting. And then finally, minimum 1 basic and 4 VIP Pass in 8 cards. You're going to see why these will differ ever so slightly as we move along. And as I already told, the top one, least likely, bottom one, most likely. So let's get to it. First, starting with the exact hand. This is also the quickest of them all in terms of calculating, because what we're doing is the following equation here. So let me explain a little bit. First, you want to draw one of your 3 Palkias in 60 cards. Then you follow this by drawing one of your trekking shoes in 60 cards. But we can also see here, you can just see here, how many zeros do we actually have when I calculate percentage? 1, 2, 3, 4. I think 7 zeros, and then 151. What a nice number, actually. But in any case, we first look at, we got 3 Palkias you want to hit. Okay. Then you got your 3 trekking shoes. Now there's only 59 cards in the deck because you drew your Palkia already. And then you follow up with drawing first 1 water, then another water. So there's 9 out of 58, then 8 out of 57. And then you go for 4 VIP passes like that. And then, so of course, 4 out of 56, 3 out of 55, 2 out of 54, and 1 out of 53. Now, I know what some may be thinking right now, but he said something about prize cards. I have a longer argument for why that makes no difference, and you can watch Pokémath episode 3 for more explanation, but in short, it doesn't make a difference. But okay, to explain a little further, whether you draw this exact hand because the deck is sufficiently randomized, I am believing that Julius sufficiently randomized his deck. We all know what that means, right? So, of course, that means that the deck is random. Actually, it doesn't matter where you draw the cards from, to be honest. Which is why, whether you place the prize cards first or after or in between, that doesn't matter. It doesn't change this here. You can look more in episode 3 to how this actually moves together. But answer here, 0.70151. Okay, cool. And for now, I'm going to put all the numbers over here on the picture so we have more space, because the following calculations, they do take a little more time, or a little more space at least. Now we go for first 4 cards in any order, then 4 VIP pass. So first, we draw Palkia V, Trekking Shoes, and Water Energy. And this is where we can use the hypergeometric distribution. So we got 3, choose 1, 3, choose 1, 9, choose 2, divided by 60, choose 4, because we're drawing 4 cards. That's not the final answer, of course, because now we still miss the other 4 VIP pass. So, of course, then we draw 4 VIP pass, which are all independent events. So you multiply all the probabilities to one another. So we take the probabilities we just calculated, 0. How many zeros are we at again? 1, 2, 3, 6, 6, 4, 4, 3, 1. We multiply that with 4 out of 56, 3 out of 55, 2 of 54, and 1 over 53, because of course we draw cards out of the deck the whole time. And then the answer in this case becomes, how many zeros are we at now? 0.1, 2, 3, 4, 5, 6 zeros, 181. So, judging by the amount of zeros, this number was a little larger now, which means it's more likely to happen. Cool, cool. So now that was 2 down, 3 to go. We're doing quite well here. So now we look at all 8 cards drawn in any order. Yes, there's a caveat to this one, of course, because we consider 3 different scenarios. Why? Because Palkia V must be in the first 7 cards, otherwise you got a mulligan going on. So that doesn't help here. But fortunately for us, why is it 3 different scenarios? That is because the 8th card can either be your trekking shoe, can be one of your water energies, or one of the VIP passes. So we calculate each of these 3 scenarios, we add them all together, and that's your answer. So let's go for it. First, we look at 3 choose 1, that's the Palkia. 3 choose 1 again, that's the trekking shoe. 9 choose 2, that is your energy. And 4 choose 3, that's the 3 VIP passes, and you multiply this by 1 over 53, because that's your turn card. That's the last VIP pass. That's number 1. Then we look at 3 choose 1, that's still the Palkia. Then 9 choose 2, the energies, all 4 VIP passes, and finally you draw your trekking shoes, which becomes 3 over 53. Okay, that was scenario number 2. And finally, it could be one of your remaining 8 water energies you draw. So 3 choose 1, 3 choose 1, 9 choose 1, because only 1 water. And then all the 4 VIP passes. And again, you always have to divide this with 60 choose 7, because that is all the possible combinations you can draw 7 cards from a deck of 60. That number is very, very large, ladies and gentlemen. And what we have to do, we have to sum all this up. We translate the percentage for convenience. And then how many zeros are we at now? 4 zeros, 11,080. Well, less zeros. We're getting somewhere. It's becoming more and more likely to happen, but this is, regardless, we're still at very, very small numbers. And we still got more to go. We got basic in the first 4, then 4 VIP pass. So now we're starting to not really care about many of the other cards. We're just making this more likely to happen, keeping the 4 VIP passes. So first we do this a little bit backwards. First, I want to calculate the probability of hitting 4 VIP passes in a row. After we take the first 4 cards out. So we calculate the ladder probability first. 4 over 56, 355, 254, and 153. You get the intermediate result here, still with a lot of zeros. And then, of course, we do no basic, no VIP pass in your first 4 cards. So that'll be 10 choose 0, because we got 10 basics in deck, and we want to get none of them. 4 choose 0, because you got a VIP pass or no VIP pass, and then you want all the 4 cards you draw from the remaining 46 cards of the deck. You divide this with 60 choose 4, and this probability is something we can put together with the first result, so weigh it, and then we're down at a result now that says 0. Oh, we only had how many zeros? 1, 2, 3 zeros, and then 40, 92, 02. This is getting relatively large number compared to what we started with, but we got 1 more to go. We got minimum 1 basic, then 4 VIP passes in the 8 cards. And here we're not talking about them in a row, we just need to hit our 4 VIP passes. We consider 7 scenarios here. We're going to explain a little more, because first, we consider scenario number 1. 4 choose 4, that's the 4 VIP passes. 10 choose 1, that's 1 basic, just a basic, and then 2 other cards. Then, of course, we have a scenario where we hit 4 VIP passes and 2 basics and 1 other card. That's the 10 choose 2, 46 choose 1. Then we can also hit 4 VIP passes with 3 basics and no other cards. That's scenario number 3. Number 4 is we hit 3 of our VIP passes, 1 basic, 3 other cards, and then on the turn draw, we get 1 over 53, that is, you hit the last VIP pass. This is important because, well, here we are assuming the basics, of course, still. And of course, we can continue this. We hit 3 out of 4 VIP passes, and then we hit, 2 basics, and then 46 choose 2. And we can just continue with the 6th scenario here, again, where you now have only 1 other card, and you still draw your last one. You have 3 basics here. And finally, we draw 3 VIP passes, 4 basics, and no other cards in the deck. That could be anything, right? Like I said, it could be water, trekking shoes, or whatever else you're playing in this deck. We get now 7 different scenarios, which we can, of course, just add all together to get an answer. And it's going to be a nice answer in percentage of 007. And 3 more zeros, 158. But you see now we're now at only 2 zeros before the first number. That's what we get at. And we can, of course, put all this together. Let's do that, actually. So we go over here. All the things we were calculating in this episode, we can put them all together. Let's go with the probabilities. And as you will quickly see, we go from top to bottom. It becomes more and more likely. I believe what Julius meant was the upper one, which is the least likely of all of them. The rest are just things that was added on. Also, maybe because it was a little ambiguous. It could be. And also some for fun, just to illustrate how it was still very unlikely to happen. And that comes to a little roundup of today's episode, because what did we learn? Well, the probability of this situation is about, how do we say this? 151th trillionth, because we have a lot of zeros. I believe this is trillionth. And actually, for a little comparison here, the probability of getting struck by a meteor lays around 1 to 1.6 million. So it's much more likely to be struck by a meteorite. And you should go and play the Powerball also, because that lays in 1 over 292.2 million, which is still a smaller thing than this. Larger number, more likely than this, which is like, wow. And of course, I also like to always say to my students when we talk about probabilities, just because something is low doesn't mean it will never happen. Just like I like to say, I got 3 bunnies in my house. They live on the ground floor. I sleep on the 2nd floor. The probability that one of the bunnies will break out of his cage, go up all the stairs, and kill me in my sleep, very, very, very low, but it's not 0. It's technically possible, I guess. So that's also a nice comparison, I guess. And with that said, this was all I had to you for today's episode of Pokémath. I hope you enjoyed this class here in Steffen's Classroom, and I hope to see you back for another class in Steffen's Classroom. Bye-bye.